let's look at couple of limitations of dimensional method or dimensional analysis. Alright, see, the first one is this dimensional analysis, it does not tell you whether the physical quantity is a scalar or a vector. Correct? Like if you take velocity, if you take speed, dimensionally both of them are one and the same, but one is a scalar, one is a vector. So dimensional method will not give you that information. Alright, the second limitation is that, see, any dimensional formula you are going to prove, it has no information about these dimensionless constants. For example, when you take t is equal to 2 pi root L by g, that is the correct formula. Instead of 2 pi, if I take 200 pi or 2000 pi root L by g, dimensionally it is still correct, but practically it's not correct. Like theoretically it's not correct, isn't it? So now dimensional analysis can give you that it is dimensionally correct, but not numerically. Okay, now this is one of the drawbacks of dimensional analysis. Now the third limitation of dimensional analysis is that if you have more than 3 basic units, like see, in all the formulas we used MLT, mass, length and time, correct? Now along with these 3, suppose if you have one more fundamental quantity, then this dimensional analysis, we cannot use it to derive the formula. Alright, now this is another limitation of dimensional analysis. Now the fourth one or the next one is basically what you see is in any of the formulas you have, most of it has 1 or 2 terms in it, correct? Maximum. Like for example, V is equal to U plus AT. You have 2 terms, U and AT. Or if you take S is equal to UT plus half AT square. Correct? Now if you take these 2 examples, the first one, V is equal to U plus AT, can be easily derived, even dimensionally also. But when you take S is equal to UT plus half AT square, here again that half is a dimensionless constant, correct? Instead of half, if I take 20 AT square or whatever number you take, dimensionally it will still be correct, whereas actually it is wrong. So when you have 2 or more terms in a formula, and if you have dimensionless constants in those formula, then dimensional method or dimensionally you won't be able to prove it is correct or wrong. This is another drawback of dimensional analysis. Alright, now you saw many advantages and disadvantages, correct? But we still use dimensional method in deriving the formula because it is quite easy to do, and it's more like a filtering process. If it's dimensionally incorrect, then you won't even go further. If it is dimensionally correct, then we'll go into the further steps. So even till today, dimensional methods are still used and it is very effective. Alright, now you saw the limitations of dimensional analysis, uses of dimensional analysis, and different types of dimensions for all the physical quantities, correct? Now in the next upcoming videos, you guys will see, now whatever physical quantity and whatever experiment you do, what are the practical difficulties you will face and what types of errors you are going to come in any experiment you are going to do. You will see these things in the next couple of videos.